Look up. No, seriously, look up at the night sky. Beautiful, right? Thousands of tiny, twinkling diamonds. But here's the thing that'll keep you up at night. What you're seeing is just the tip of a cosmic iceberg so massive, it's statistically insulting. In our galaxy alone, there are up to 400 billion stars. And thanks to the Kepler mission, we now know that almost every single one of those stars has at least one planet. If we narrow that down to just Earth-like planets, rocky, not too hot, not too cold, has a decent chance of not being a literal hellscape, we're still looking at roughly 40 billion candidates in the Milky Way. Even if life is so rare that it only happens on 0.1% of those planets, that's still 40 million civilizations. 40 million in our backyard. So, where are they? Seriously, where is everyone? The universe is 13.8 billion years old. Earth is only 4.5 billion. That means there's had to be plenty of time for some ambitious alien species to invent FTL travel, build a Dyson sphere, or at the very least, leave a glowing "Kilroy was here" neon sign on the moon. But instead, we get silence, static, the great cosmic read receipts with no reply. This is the Fermi Paradox. It's the gap between the high mathematical probability of aliens and the total lack of evidence that they actually exist. It's like throwing a party, sending out 1 billion invitations, and then sitting alone in your kitchen eating lukewarm pizza because nobody showed up. Now, there are a lot of theories. Maybe they're shy, maybe we're the first ones to the party, or maybe, and this is where it gets spicy, maybe there's a reason the universe looks like a graveyard. Enter the Great Filter. It's the idea that there is a wall, a catastrophic evolutionary or technological barrier that almost no civilization can climb over. And today, we're going to find out if we've already cleared that wall, or if we're currently sprinting full speed toward it. Grab your tinfoil hats and your existential dread, folks. It's time to talk about why civilizations die. Okay, so let's talk about the Great Filter. Think of the development of a spacefaring civilization not as a smooth ramp, but as an incredibly difficult obstacle course. To go from single-celled goo to intergalactic empire, you have to pass a series of checkpoints. Checkpoint 1, can you even get life started? Checkpoint 2, can you make that life complex? Checkpoint 3, can you use tools without accidentally poking your own eye out? And finally, can you survive the discovery of high-energy physics? The Great Filter is the idea that at some point on this timeline, there is a step so impossibly hard, so statistically improbable, or so inherently dangerous that almost nobody makes it through. It's the reason the galaxy isn't buzzing with alien TikToks. The filter catches them and, well, it deletes them. But here's the real kicker, the part that keeps astrobiologists awake at 3 a.m. The danger of the filter depends entirely on where it sits relative to us. If the filter is behind us, we are the chosen ones. We are the 1 in a trillion fluke that survived the impossible. Maybe the jump from bacteria to complex cells is so hard it only happens once per galaxy, and we won the cosmic lottery. Yay us! We're the smartest guys in the room because everyone else died in kindergarten. But if the filter is ahead of us, if it's something like the invention of the atomic bomb, or the creation of a hostile AI, or total climate collapse, then we're in trouble. It means every civilization hits a certain level of tech and then they vanish. It means the great silence we hear isn't because we're first, it's because we're next. This leads to a really weird realization. In this context, finding life on Mars would actually be terrible news. If we find simple bacteria on Mars, it suggests that life starts easily. And if life starts easily, then the filter isn't starting life. It must be further down the line. The more life we find in the universe, the more likely it is that there's a giant, civilization-eating monster waiting for us in our future. As philosopher Nick Bostrom put it, the silence of the night sky is golden, because the discovery of even a single fossil on Mars would be the worst news ever printed on a newspaper cover. So, let's look at our past. Are we actually that special? Or are we just early to our own funeral? Okay, let's breathe a sigh of relief for a second. Let's look at the possibility that we've already cleared the hurdles. What if the great filter is something we did millions or even billions of years ago? First candidate, abiogenesis. The jump from dead rocks and chemistry to living, breathing biology. We like to think life is inevitable, but what if it's a fluke? What if the specific sequence of lightning hitting a primordial soup at just the right temperature is a 1 in a septillion shot? If that's the filter, then the universe is empty because the spark almost never happens. We're not just special, we're a chemical miracle. But wait, it gets more specific. Let's talk about our home. Earth isn't just a rock, it's a luxury suite. We have a huge moon that stabilizes our tilt, giving us steady seasons. Without it, Earth would wobble like a drunk top, swinging between eternal ice age and boiling desert every few thousand years. Not exactly great for evolving a brain. We have Jupiter, the solar system's bouncer, using its massive gravity to suck up asteroids that would otherwise be slamming into our face every Tuesday. And we have a magnetic field that keeps the sun from stripping our atmosphere away like a leaf blower. If the filter is having the perfect planet, then we might just be living in the only 5-star hotel in the galaxy, while everyone else is stuck in a cosmic dump. Even if you have life, and even if you have a nice planet, you still need intelligence. And not just, hey, I can hide from a predator intelligence. We're talking, hey, I can harness electricity intelligence. Dinosaurs were on this planet for over 150 million years. They were successful, they were fast, and they were scary, but they never built a telescope. Evolution doesn't want to make humans. It just wants to make things that survive long enough to have babies. Maybe the jump to abstract thought and technological capability is the real filter, and we're the only ones who tripped and fell into the smart category. If any of this is true, the great silence is a gift. It means the hardest part is over. We've survived the gauntlet, and the stars are ours for the taking, right? Okay, take that feeling of being a cosmic miracle and tuck it away for a moment, because now we have to face the darker possibility. What if the filter isn't behind us? What if it's waiting for us, right around the corner? Think about it. In the last 100 years, a blink of an eye in cosmic time, we've gone from riding horses to splitting the atom and creating global computer networks. We've gained the power of gods, but we're still carrying the brains of competitive, tribalistic primates. The great filter might just be the tech trap. Maybe every civilization, once it discovers nuclear energy or nanotechnology, inevitably ends up using it to turn their planet into a glowing glass marble. It only takes one bad day and one big red button to exit the galactic stage forever. And it's not just bombs. We're currently playing with fire in ways our ancestors couldn't imagine. There's artificial superintelligence, the moment we build something smarter than us that decides we're just a collection of atoms it can use for something else. Or biotech, where a bored teenager in a basement creates a virus that makes the Black Death look like a common cold. The filter might be a sovereignty gap, the gap between the power to destroy a world and the social maturity to not do it. If this is the filter, the reason we don't hear from anyone is that every civilization eventually builds its own executioner. But wait, there's an even spookier explanation. What if they aren't all dead? What if they're just hiding? Welcome to the dark forest theory. Imagine the universe is a dark forest at night. It's full of hunters. A hunter has to be quiet, because if they make a sound, another hunter might see them as a threat and strike first. In this scenario, the Great Filter is simply the first civilization that decided to delete anyone else who makes noise to ensure their own survival. We've been broadcasting our location with radio waves for decades, like a toddler screaming in a room full of snipers. If the galaxy is a dark forest, our hello might be the last thing we ever say. So, where do we sit on the danger meter? Right now, we're a Type 0 civilization. We still get our energy from dead plants and dinosaur juice. We haven't even mastered our own planet's climate, let alone our solar system. According to the Kardashev scale, a way of measuring how much energy a civilization uses, we have a long way to go before we're even visible on a galactic scale. We're basically cosmic toddlers playing with matches in a basement. Many scientists believe we are currently in the most dangerous period of human history. We are in the transition from Type 0 to Type 1. This is the bottleneck. We have the technology to destroy ourselves, but we don't yet have the technology to leave our cradle and colonize other planets. We're like a baby trying to cross a highway. If we make it to the other side, if we become a multi-planetary species, our chances of survival jump to almost 100%. But until then, we're one asteroid, one pandemic, or one bad political tweet away from the filter. So, that's the menu. Either we're alone because everyone else is dead, or we're alone because we're the first ones to arrive, or we're alone because everyone is hiding under the bed. It's a lot to take in. It makes our daily problems, like a slow Wi-Fi connection or a burnt toast, seem pretty insignificant when compared to the literal survival of sentient thought in the cosmos. But here's the secret. The Fermi Paradox shouldn't make you feel hopeless. It should make you feel empowered. If the universe is indeed a vast, empty library, then we're the only ones currently writing the books. We are the eyes, ears, and the messy, complicated conscience of the Milky Way. If we fail, 1 billion years of potential art, music, science, and love might simply evaporate. The Great Filter is a test. It's a test of whether a species can value its future more than its immediate greed. It's a test of whether we can learn to cooperate on a planetary scale before our toys become too dangerous for us to handle. We don't know if we're the chosen ones or the next victims, but we do know that we have the steering wheel right now. We are currently the only known part of the universe that can wonder why the universe exists, and that is a privilege worth fighting for. We have to keep looking up, keep exploring, and for the love of all things holy, try not to break the planet before we figure out how to leave it. The silence of the stars isn't a death sentence. It's a challenge. It's a blank canvas waiting for us to paint it. So let's make sure we stay around long enough to finish the masterpiece. Thanks for watching Criterion. If you enjoyed this dive into the cosmic void, hit that subscribe button. It's the best way to let the algorithm know we're still here. And hey, if you are an alien watching this from a cloaked ship, drop a comment. We promise we won't bite much. Stay curious, stay grounded, and we'll see you in the next one.